Hi everyone, in this video I will continue the discussion on the definitions in the friction model, and this one is velocity normal force definition for the friction model, and the model that I need to choose is velocity normal force dependent, right? I have some uh, information given here. So this is the constant for friction coefficient at low velocity. This one is for the exponent for coefficient of friction at low velocity. And then this one is the constant for coefficient of friction at high velocity. Similarly, this is the exponent of coefficient for friction at high velocity, and we have this constant rate parameter coefficient and linear rate parameter coefficient, as well as quadratic rate parameter coefficient and maximum coefficient factor for the determination of coefficient of friction. And in this value, as shown here, prevent the friction coefficient from exceeding an unrealistic maximum value when the normal force become really small. So uh, and that's why this maximum friction coefficient is determined from these fast for and slow determinations of the constants here. So let's look at the OpenSees command here, and let's discuss it here. Um, these are the uh, coefficients for the theoretical background here, and yeah, it's basically cover some conditions on the definition here. So now, before going forward, let's discuss how you can write them in OpenSeas. So to do that, for example, I have this uh, information file, and I will call it velocity normal friction definition file, and I will um, rename it with this file extension of tickle. So um, I have to edit it here, and this basically require you to be defined in input information, right? And in the input information, you can write a section like definition for the velocity uh, normal force independence definitions, right? And you can include limits, etc., whatever you want to include in your file. And gradually, slowly, I am showing that how it can be done in the OpenSeas as well as in the STKO here. So the first thing that you need to define is define the NV flow, right? And we discussed this here as well. I'm uh, very careful about putting comments for making it more user friendly here. So let's look at here. This is a slow, right? And constant for coefficient of friction at low velocity, right? And we have this alpha 0 and linear rate parameter. Similarly, We have this alpha 2 and maximum friction, right? So the order does not depend on putting all these parameters, right? So you can set them and you can do whatever you want with it. You can write the definitions, making it easier for yourself, as including comments in your file and so on. Whatever you want to do, you can do it. And the rule is, let me go to um, tools, um, language, taken. This is the language here. So it's okay. Every time you put comments, you need to insert the hash before adding it, and without uh, setting any comments, you can then include the uh, commands in your file. So slow is 0.12, for example. This is the command that is required here. Uh, Low friction coefficient, and this is the fast 0.18. And you notice that when the vibration is increasing, the coefficient of friction is increasing. When the vibration is decreased, the coefficient of friction is less. This is because the reason is the molecular behavior is resisting the friction here. So that's how it's working. But after some time, decay is occurring in this model, so we can discuss it here. So let's discuss this by including it as well here, as per the OpenSees documentation here. And let's say set and fast of zero point 0.7 and then set. Um, there is a rule of Taker language. I'll try to include that in this video discussion as well. And when you are working with Taker files, you will be able to study it in your syntax practice to discuss the commands with your supervisor or with your colleagues by practicing it and making those files. So let's make it set alpha 1 zero point 0, then set alpha 2 0.0. I think these are 2, 3, 4, 5, 6. I need to define alpha 0, alpha 0. Right? You don't need to put any comma, etc. in your model. And when you include this definition in your OpenSees file, you'll be able to consider it by making it in your uh, input files for the taken program, right? So the rule is simple. Um, Now let's go to the friction tag here, with how this friction tag is considered here, right? So OpenSeas has this command syntax. So we can say command for the velocity and normal force depending friction here. And for your own safety, you can use this as well. So the friction model is as it is, that is given here, and the velocity normal force, this is the friction model. The friction tag, it will be 1, 2, or 3, whatever you are using in your file, that is decided here. So for example, if I click on it, the friction tag will be 2, and A slow, N slow, right, mu slow, and A fast, and set maximum and U fit. Um, you can define this function as maximum and U fit here. So by making things easier for yourself, you guys can include the commands here as well. For example, this is the unique friction tag in your model. Similarly, if I copy these for my understanding, I can um, use them here as well. And I think I should use these comments in the syntax for the vectors, so that whenever you are practicing, you have a better understanding of using this modeling environment here. So setting fast, I'm sorry, setting fast should be here. And let's copy it here. This MU slow is not the unique friction tag. The unique friction tag is this one, FRNTAG. So I need to not include it here at this point in the input information, because I had to use it in the friction model. So constant of rotation for low velocity, um, this should be here. Um, for high velocity, this should be here. And so on. You can include all these information in your file. So for alpha 0, concentrate parameter coefficient, and this is given here. Similarly, for alpha 1, linear rate parameter coefficient, and paste it here. Similarly, this is quadratic rate parameter coefficient, so I can use it here. And I think the last one is minimum NU effect, the factor for determination of the maximum coefficient of friction. So this is for the factor of safety, uh, right? Um, and it's very important to consider. So you can make this as a uh, breakthrough comment, and this is, I think, the professional way to consider your model. That's okay. Anyways, I think it is self-explanatory. So you can do whatever you want with it, right? And whatever discussion you want to include in your analysis. Um, According to the OpenSees documentation theoretical background, um, if you define a slow, let's include it here in this discussion. Let's look at the theoretical background and look at the behavior, what they are trying to discuss here. So um, it's given here. The definition of new slow is actually the product of a slow multiplied by n raised to the power n slow minus 1, right? Exponential of coefficient friction at low velocity and exponential of coefficient at high velocity. Um, this is according to their definition, and they are telling us that if we are using these NU slow and NU fast, so we can take help from the OpenSeas documentation by specifying it that N slow should be less than or equal to 1 and N fast should be less than or equal to 1 that are constant that determine the friction coefficient model. So N slow, so this is basically N slow, right? This should be less or equal to 1. This is a comment that we need to include. And fast, this should be less or equal to 1, right? So this is a note you should include in your tackle file, right? And you should be careful about including these comments in your OpenSeas file. So if it is greater than 1, it means that you are doing some mistake in it, and these friction coefficients are against the law of friction, and that is because if you are considering the n slow and n fast greater than 1, it means that you are exaggerating the model, and if the friction coefficient are increased in greater than unity, it means that whatever force you are applying on the model, the output will be larger than that force, which is against the equilibrium condition and friction losses. So it's important. And the second point that they are trying to mention here is the friction coefficient as a function of um, velocity. So they also have included this. You view that is the velocity of the sliding interface and the rate parameter. Rest everything I define. So um, another thing, according to the nomenclature that they have included here, according to the documentation that they have included here, this is the important point to consider that this friction model A is assumed to be dependent on axial force N, right? So this A is also included here. And the units are important if you are defining these constant in your OpenSeas file. So alpha naught, alpha 1, and alpha 2 will have the unit of time by length by force, and time by length by force square respectively, which means that alpha naught is for time by length, alpha 1 is for time by length by force, and other one are given here. So this is the function with vertical forces, slow friction, fast friction, and fitted curve here, and it is derived from this theoretical background here. And as I mentioned, for the special cases, if we are discussing the special cases for the constant friction coefficient, uh, all the other constants are arbitrary, and for the vertical forces, they are not considered here. And this is the for the dependency of the considerations here. So just in case if you are not aware of the syntax, you can just copy it, and then you can paste it directly in your file, and then uh, use it, right? And both works the same way. Whatever is convenient for you, you can use them in your analysis. And this is the function here. But as I mentioned here, that this is the second model. So for example, this definition that I used here in this analysis, for example, at 0.12, uh, and slow, and fast as low as, for example, 0.1, 0.18, a fast is, example, 0.2, and fast is 0.3. For example, alpha naught is 25, alpha 1 is 0, alpha 2 is 0, and your multi effect is, and this is 1 or 0.2, 0.3. For example, if I want to make it 0.3 here, and I click on OK. So if I'm writing the tickle file, this should be 2 instead of 1, right? Just, the other is the syntax, right? And in fast, alpha naught, alpha 1, alpha 2, and then you have this 3.0 is a maximum limit for the analysis that we are trying to use here. So this is for the tickle file, and you can further explore the documentation for your analysis files. And this concludes the velocity normal force definition. And if you have normal force definition inclusion in your model, you can use them in your implementation of the files here. So overall, there are various possibilities with the modeling environment that we are using here, and I think I will discuss the um, last model, velocity pressure definition. Then I will go to the limit curve definition. So the friction model definition is completed, and then we have some miscellaneous definition, random variables, and time series. So this is very interesting topic. I wish I can explain it further, and I dive into the discussion. It's really interesting. It's really easy to understand when you are trying to demonstrate it and then understand it here. But this chapter is very lengthy, so I'll try to um, cover as much as I can in a short way, because after definition, I will go to the physical properties for the materials, and I have a lot to discuss in the materials definition, similarly for the section, and for all these parameters. So it's a pretty lengthy course, and then we have this element property definition. So it's a 2-3 months discussion, and honestly, if this is completed in this way, then I think analysis will not be difficult to consider in the OpenSees. Thank you so much for watching.